Hi, my name is Siti from University Technology Petronas. Today, along with my co-authors, Professor Manuel Pebrile and Dr. Benjamin Sauter, we would like to share our recent findings from utilizing the airborne gravity and aeromagnetic data which was acquired by Bell Geospace in 2014 in our country with all of you. So this presentation is actually based on our recent paper, which was published in special issue evaluation of the crustal structure in MDPI Applied Sciences Journal. The title of the paper is Shallow versus Deep Subsurface Structures of Central Luconia Province in Offshore Malaysia revealed by Aeromagnetic, Airborne Gravity and Seismic Data. So before we go further, let me introduce where is the location of the study area. The study area is located in offshore of Sarawak. Sarawak is a state within Malaysia and it is in the island of Borneo. So the airborne gravity survey was acquired in this section of offshore Sarawak, which covers the central Luconia to southwest Luconia Graben. This area is actually subdivided structurally into regional highs and lows that are further partitioned into localized extensional holes and grabens that trending in systematically in south-southwest, north-northeast, while some compressional events are also detected, some compressional structures are also detected with trending of west-southwest, east-northeast. The grey circular and elongated structures morphology over here in this map is actually showing the top carbonate of cycle 4 and 5 limestones which were deposited during middle to the upper Miocene. So if we see the orientation of the carbonate build-ups directed in different orientations. Some of them are in north-south, some of them are east-west, even northwest, southeast, and so on. So this had give a motivation to us to study further on the orientation of these carbonate build-ups. Is it have something to do with the structures underlying it? And our aim is actually to make use the recently acquired data of airborne gravity and aeromagnetic data from this area to deduce the subsurface orientation in this study area. Actually, we have very little information on how the basement or the crust of central Luconia behave. We know it has been rifted and traveled so long from the southern China during Cretaceous until it docks with the Sarawak mainland during Oligocene. But then, after that, lots of sediments deposited on top of it and developed a prolific hydrocarbon reservoir within the carbonate build-up. So we would like to utilize this data and study if it has it can give us new information about the basement of this area. So what we did was we selected the air FTG and aeromagnetic data, and then because the air FTG has lots of tensors and lots of data selection, we utilize the depth tensor. So from the depth tensor we have TZ, TZZ, TXZ and TYZ. So these cover the low frequency, high frequency, as well as the vertical and horizontal domains of the depth tensor. So from there we analyze and identify the lineaments. This is one of the examples of the TZZ data. And as well as we also use the aeromagnetic data from the total magnetic intensity that has been reduced to the equator and its derivative. Also the analytical signals of the residual and regional data from the aeromagnetic to study the deeper subsurface of central Luconia. From there, we extract a depth profiles and then we cross-examine it with our seismic data and well data where available. So this is one of the example showing the depth profile. The green lines are showing the shallow subsurface, while the or low short wavelength data, and the blue lines are showing the long wavelength data. So we can correctly put the signatures of these depth profiles with the seismic data, and it coincides nicely with the top of the carbonate on the shallow subsurface and with the possible cycle 1 or cycle 2 sediments, and that might reflect the crustal behavior underneath it. After that, we also compare with the published map in this area, and then we start doing the evaluation of the regional and local faults. So let's see what we got over here. So from the aeromagnetic data, most of the data reveals east-west structures and variables of other orientation, such as in northwest-west, southeast-east, and northwest-southeast. From the airborne gravity, on the other hand, most of the data from the airborne gravity reveals consistent northwest-southeast orientation, and some of them also recorded north-northeast, south-southwest, and northeast-southwest. So what we can deduce here, the aeromagnetic has produced strong east-west morphology or orientation, while the airborne gravity comes up with northwest southeast orientation. So what we do is we compare with the published map. This is one of the tectonic map from this area. So our study area is located over here. This is very small, and then we can see the whole South China Sea, present day South China Sea over here. So what we can see, the northwest southeast structure that were acquired or were deduced from the interpretation from the airborne gravity is actually parallel with most of the major faults in this region. This is one of the example, like Red River Fault over here, Maf Peng Fault Block over here in southern Vietnam, and then we also have Pestanotter Fault over here, and basically our region over here has lots of northwest southeast fault. So that is what the airborne gravity deduced. So there's nothing new about it. But interestingly, what we see from the aeromagnetic data is actually mainly the east-west transition. So these bold lines over here is showing the east-west orientation that we deduced from the aeromagnetic anomalies map. This east-west orientation is actually has never been published or have never been mapped in any articles or any publications. So this is, where do we get this east-west? Does it make any relevance in this region, since all the other faults that were mapped are oriented in northwest southeast? So the east-west orientation is actually was revealed by the first derivative and analytical signals of the aeromagnetic data. So this is actually parallel to the southern variation of the Crocker and Rajang Fold thrustback, which is in the onshore of Sarawak. There is also a potential high angle fold in the east-west direction. So this high angle fold in the subsurface is observed on the magnetic data, and this is actually postulated to be the southern boundary of the Palawan, which is in the north in Philippines, where the southern boundary of the Palawan continental block accretion with the Luconia crustal block in long time ago during the closure of Proto-South China Sea. There is also one evidence from the depth profiles that shows there is undergoing deep structure towards the underneath of mainland of Sarawak. So there is a potential accretionary wedge or subduction zones underneath Sarawak, although we have never seen this, but this has been modeled by many scientists before, and with this addition of new knowledge, we think we have updated the understanding, improved the understanding on the tectonic evolution and the crustal basement of this area. So, in summary, the different tensor components that are available from the airborne gravity and aeromagnetic data provide an options for all of us to use it wisely, select the data correctly for the purpose or the objective of your study, and then you will be able to utilize it for the purpose of your study. So as example, in our study area in Central Luconia, since we have little information about the basement, we utilize the both aeromagnetic and depth tensor from the gravity data to validate the subsurface, and now we have re-evaluated the structural orientations in this basin at distinctive depth ranges. We have north-northwest, south-southeast striking, and this is actually the same direction for the rifting faults during Cretaceous that stretch the continental crust, and it is actually very relatable with the regional trend that we see in Vietnam and as well as in Kalimantan. Apart from that, we have new findings, which is the aeromagnetic data reflects east-west direction or morphology of potential basement. And this could be is not fully understood yet because this is the first time that we see it, but it could be corresponding to the trace of subduction of Luconia continental shelf underneath central Borneo, and it might represent the southern boundary of the accretion between Palawan and Luconia crustal block. So in this area, we have lots of tectonic models, and it is still uncertain which is the correct one. We know that there is potential subduction zones underneath Borneo or underneath Sarawak. So these structures that we see in east-west direction as well as in depth profiles might be one of the new thing that we are able to show to the scientific community, to the geoscientist community in this area, that there is evidence of subduction zones, potential subduction zones underneath this area. So before I end my presentation, I would like to use this opportunity to thank to Bell Geospace, especially Mr. Roy Kittrell and Dr. Cor Murphy for the opportunity to collaborate, and special thanks to the owner of this data, which belongs to Malaysian Petroleum Management of Petronas, for releasing the data for scientific study. If you have further discussion to us or to discuss with me, you are welcome to contact me either through my LinkedIn as seen in these slides or through my email at fathiyah.jamaludin@utp.edu.my. With that, I thank you and bye.